Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. A bus needs to cover a distance of 300 kilometers and arrive at its destination on time. However, it started 1 hour early and reduced its speed by 50 km per hour so that it arrives on time. Find the usual speed of the bus. Now, it started the journey 1 hour early and to arrive on time, it reduced its speed by 50 kilometers per hour. So you can also say that if you reduce your speed by 50 km per hour, it will take an extra 1 hour. That it started 1 hour early and arrived on time. So it has actually traveled for 1 hour more. Now we'll form the equation. You have the basic formula, distance by speed gives you time. Now a bus needs to cover a distance of 300 kilometers. So distance is 300. Now first we'll find out the time when you have reduced your speed by 50 kilometers per hour. Regular speed is s minus 50. So this is the time required when you have reduced your speed by 50 kilometers per hour. Next we'll find out the time when you're traveling at the regular speed s. That is distance is 300 by regular speed is s. And when you're traveling at a speed reduced by 50 kilometers per hour, you will take an extra 1 hour. So this difference is equal to 1 hour. So this is a basic equation. Now the question is find the usual speed of the bus. So S is what we need to find out. So you just need to solve this equation and calculate the value of S. This is the equation that we have. Now if you try to solve it, you will get a quadratic equation. Now when you get a quadratic equation, rather than solving the equation, you can go from the options. Going from the options is generally quicker. Now the solution to this equation is the answer. Rather than solving and calculating the solution, you can go from the options. From the options, identify the one that satisfies this equation. The one that satisfies this equation is the solution and that will be the answer. So from the options, we'll identify the one that satisfies. For example, let us try S is equal to 150. Let us see if 150 satisfies this equation. That is, left hand side of the equation should also be equal to 1. Then it will satisfy. So we'll try for S is equal to 150. So 300 by, we are assuming S is 150. 150 minus 50 is 100. Minus 300 by S. S is 150. We are assuming it to be 150. We'll just calculate. Zeros will cancel out. So that will be 3. Here 0 and 0 cancels out. 15 divides 2 times. So this is 2. So 3 minus 2 is 1. So you can see here it satisfies. Left hand side is also 1. Right hand side is also 1. So S is equal to 150. It satisfies this equation. So 150 is the solution to this equation. So find the usual speed of the bus. S is equal to 150 kilometers per hour. Option B. The destination of an aeroplane is 1500 kilometers away. However, since it started 30 minutes late, its pilot had to increase its speed by 250 kilometers per hour so that it arrived on time. What was the usual speed of the aeroplane? So we can say that if you increase the speed by 250 kilometers per hour, it actually takes 30 minutes less. That is, it started 30 minutes late and it increases speed by 250 kilometers per hour and it was able to arrive on time. So if you increase the speed by 250 kilometers per hour, you will take 30 minutes less. So we'll form the equation like that. Now you have the basic formula. Distance by speed gives you time. So this is the basic formula. The destination of the aeroplane is 1500 kilometers away. So distance d is 1500. Now first we'll find out the time required when it is traveling at its usual speed s. So distance by the regular speed is s. So this is the time required when you are traveling at the regular speed s. Next we'll find out the time required when you have increased the speed by 250 kilometers per hour. Distance is 1500, by speed is now s plus 250, and this time is 30 minutes less. So this time minus this time, that difference is 30 minutes. Now this speed is 250 kilometers per hour. So we'll convert minutes into hours. So we'll convert 30 minutes into hours. You have to divide by 60. So 30 minutes is same as half an hour. So you just need to solve this equation and calculate the value of s. What was the usual speed of the aeroplane? So s is what we need to find out. Now if you try to solve this equation, you will get a quadratic equation. Now generally it is quicker to go from the options rather than solving the quadratic equation. That is, a solution to this equation is the answer, or from the options we will identify the one that satisfies this equation. The one that satisfies this equation will be the solution, and that will be the answer. So we'll try various values and identify the one that satisfies. That will be the solution. So this is the equation. We'll try various values. For example, let us try s is equal to 750. So we will see if this value satisfies this equation or not. So 1500 by s. S we are assuming it to be 750. Minus 1500 by s plus 250, that is 750 plus 250 gives you 1000. Now 750 into 2 is 1500, so 750 divides 2 times. 2 minus here 1500 divided by 1000, that is 1.5. So 2 minus 1.5 is half, so that is equal to the right hand side. So you can see that 750 satisfies this equation. So the usual speed s has to be 750 kilometers per hour. So what is the usual speed of the aeroplane? 750 kilometers per hour, option A. The destination of an aeroplane is 3000 kilometers away. However, since it started 1 hour late, its pilot had to increase its speed by 500 kilometers per hour so that it arrived on time. What was the usual speed of the aeroplane? So you can see that if you increase your speed by 500 kilometers per hour, it actually takes 1 hour less. That is, it started 1 hour late, and by increasing the speed by 500 kilometers per hour, it was able to reach on time. So if you increase the speed by 500 kilometers per hour, it takes 1 hour less. Now we'll form the equation. You have the basic formula. Distance by speed gives you time. Now first we'll find out the time required when it is traveling at its regular speed s. The destination of an aeroplane is 3000 kilometers away. So distance d is 3000 kilometers divided by regular speed s. So this is the time required when it is traveling at its regular speed s. Next we'll find out the time required when it has increased the speed by 500 kilometers per hour. Distance is same, 3000, by speed is now s plus 500, and this time is 1 hour less. So you just need to solve this equation and calculate the value of s. Question is, what is the usual speed of the aeroplane? So s is what we need to find out. Now if you try to solve it, you will get a quadratic equation. Now rather than solving the quadratic equation, you can go from the options. Solution to this equation is the right answer. Or from the options, you can identify the one that satisfies this equation. One that satisfies this equation is the solution, and that will be the right answer. So we'll try various values and see which one will satisfy this equation. For example, let us try s is equal to 1000. So we'll see if 1000 satisfies this equation. If it satisfies, then it will be the solution, and that will be the right answer. So we'll try s is equal to 1000. So 3000 by s, we are assuming it to be 1000, minus 3000 by 1000 plus 500, 1500. Here zeros will cancel out, you will get it as 3. 3000 by 1500, that is 1500 divides 2 times. So 3 minus 2, you will get it as 1. So you can see that that is equal to the right hand side of the equation. So S is equal to 1000, it satisfies. Hence the solution is S is equal to 1000. So what is the usual speed of the aeroplane? S is equal to 1000 kilometers per hour, option A. A person needs to travel a distance of 85 kilometers. He covers a part of the distance at 50 kilometers per hour. So we will assume that initially he travels x kilometers and the speed is 50 kilometers per hour. So we'll find out the time for that. Distance is x by speed is 50. So this is the time required to do the first part and the remaining part at 25 kilometers per hour. So we'll find out the time for the remaining part. If one part is x, then the remaining will be 85 minus x. So that x plus 85 minus x, it will add up to 85. It has to add up to 85. So remaining part is 85 minus x, and for that the speed is 25 kilometers per hour. Here it is mentioned, if he takes 2 hours to complete the whole journey, find the distance travelled at 50 kilometers per hour. So time required for the first x kilometers and time required for the remaining distance, total time is 2 hours. Now find the distance he travelled at 50 kilometers per hour. So initial x kilometers he travels at 50 kilometers per hour. So x is what we need to find out. So we'll just solve this and calculate the value of x. Now LCM of 50 and 25 is 50. So I'll multiply throughout by 50, so all the denominators will go off. So 50 into x by 50, 50 into 85 minus x by this 25. 50 into 2 gives you 100. 50 and 50 cancels out. 25 divides 2 times. So you will get it as x plus 2 into 85, that is 170, minus 2x is equal to 100. So x minus 2x, you will get it as negative x. That is equal to 100 minus 170, that will be negative 70. So x, you will get it as 70. So x is the distance that he initially travelled at 50 kilometers per hour. Find the distance he travelled at 50 kilometers per hour, that is x, and x is equal to 70 kilometers, option B. A person needs to travel a distance of 50 kilometers. He covers a part of the distance at 2 kilometers per hour. So first we'll find out the time required for that part of the distance. So we will assume that initially he covers x kilometers and its speed is given as 2 kilometers per hour. So time required is distance is x by speed is 2. So this is the time required for the first x kilometers and the remaining part at 3 kilometers per hour. Now total distance is 50 kilometers. One part is x, then remaining will be 50 minus x. So 50 minus x plus x, it should add up to 50. So if one part is x, then the other part will be 50 minus x. And time required for this is the distance by speed is 3 kilometers per hour. So this is the time required for the first x kilometers plus time required for the remaining distance. And if he takes 20 hours to complete the whole journey, this total time is 20 hours. Find the distance he travelled at 2 kilometers per hour. So x is what we need to find out. So we'll just solve this equation and calculate the value of x. Now LCM of 2 and 3 is 6. So we'll multiply by 6. So all the denominators will go off. So 6 into x by 2 plus 6 into 50 minus x by 3, that is equal to 6 into 20. 2 divides 3 times, so that will be 3x. 3 divides 2 times, so 2 into 50 gives you 100 minus 2x. That is equal to 6 into 20 gives you 120. So 3x minus 2x is x. X is equal to 120 minus 100. So that you will get it as 20. So that is x is equal to 20 kilometers. find the distance he traveled at 2 kilometers per hour. We have assumed that initially he travels x kilometers at 2 kilometers per hour and x is equal to 20. So option A, 20 kilometers. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only rupees 200. So all that you need to do is make a payment of rupees 200 either through Google Pay or through Phone Pay or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.